Looking at this particular integral, we have a couple of choices here. First choice is that we could do some algebra. We could take 2x squared minus 5, raised to the 8th power, and you'd have to multiply 2x squared minus 5 times itself 8 times. Not a good choice. So the second choice would be to say, well, maybe we should be thinking u substitution. And u substitution works if you have part of the problem being u and the derivative being the other part of the problem. And it's kind of counterintuitive because when you're integrating, you think, what am I doing taking the derivative? But that's the way u substitution works. Now, u is often hiding inside of a parentheses. And in this problem, that's where it's at. If we let u equal 2x squared minus 5, the derivative of that is 4x dx. And this problem is almost set up perfectly. We certainly have the 2x squared minus 5. Now, we need 4x dx, and we have 36. But we can take care of that pretty easily. Now, we know that 9 times 4 is 36. So let's break that 36 apart. We'll put the 9 out front of the integral. We have an integral then of 2x squared minus 5 to the 8th power, and put that 4x dx at the back. And now we're perfectly set up for a u substitution. When doing u substitution, it's important to change the entire x problem into a u problem. So what I've done here is I still have my 9 out front, and we have an integral now of, instead of 2x squared minus 5, I have a u raised to the 8th power, and 4x dx turns into du. We perform our calculus by using the power rule. We now have 9 times u to the 9th over 9, and that's equal to u to the 9th. And back subbing, we get a solution of the quantity of 2x squared minus 5 being raised to the 9th plus c.